Hi, everybody. So we are going to be looking at waves and matter today. This video hopefully will help you solve the problems that I assigned last night, which are the calculating wavelength, frequency, and energy. And so if you want to skip to the end of this video, that's probably where that's going to be, but I'm going to run through some preliminary stuff first. Also, I posted the video of the meeting that we had yesterday, like at 1:15. If you want to look at that specifically shows you how to solve the problems like number 1 and 2 under the reviewing concepts or whatever that was on that packet, that reading packet. Had the math problems on it. So anyways, but that's all available for you. Here we go. Waves and matter. All right. Can you name the 7 parts of the spectrum? Okay. The way that I remember this is it's GAX, UVimmer. GAX, UVimmer. So you have gamma radiation, X-ray, ultraviolet, visible light. And then you have the immer part, infrared, microwave, and radio. This slide will give you all the processes. It tells you what it's used for. Gamma radiation is the most dangerous kind, but it's also the kind that can help treat cancer. They use gamma radiation for cancer treatment. And then it goes all the way down to radio. Radio is the least dangerous because of its wavelength and frequency. It's a real low frequency wave, carries very little energy with it compared to like gamma radiation and X-rays and ultraviolet. Okay, so there's your 7 parts of the spectrum. I do expect you to remember those, and I expect you to remember them in order. Gamma being the highest energy, radio being the least. Remember, the way that I remember this is GAX, UVimmer, gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio. Okay. Your activity this week, we watched that video, the tour of the EMS. We took some notes. If we were in class, this is what I'd planned. We were going to get a diffraction gradient, which is basically like a thing you hold up to light and it splits the white light. And you can, every element has its own little spectrum, its own little unique spectrum. It gives off its own bit of radiation. And we watched in the Poisoner's Handbook, they talked about this. They use the spectrum to solve a crime in one part of that Poisoner's Handbook. So anyways, we won't get to do that right now. Maybe when we get back. All right. So then why does each light have its own spectrum? Okay. Well, electrons absorb energy. When electrons get energy taken in, when they absorb this energy, they get super excited. Electrons will absorb this energy and then they get really excited and they move up to a higher energy level. Now, they can't stay there. Eventually, they have to let that energy go. And so when they let that energy go, poof, it usually goes off in the form of energy. And sometimes you can see it. They give it off in visible light that you can see. And so like fireworks on the 4th of July work this way. They absorb the energy from the match. They get excited. Then they have this burst of energy and they go back to their normal position. Okay. So, but electrons, that's how they're going to give off these certain types of energy. Whenever they absorb it and then they release it, it falls into some part of that spectrum. Okay.